We are going to cover a number of topics in this first lecture. It will be divided into a number of shorter or short videos. Only a few topics will be new to most people, and I will tell you when the topic is new. It actually, they will come in the next couple of videos in the first few slides of the PowerPoint. So let's see what this paradigm involves, object-oriented paradigm involves. This should be familiar to you, although you may not have thought about this in any great detail. In the object-oriented paradigm, we think of a system, a software system, as consisting of a number of objects. So the system is here, that is in blue. It contains a large number of objects or a small number of objects, depending upon the size. And we look at the objects, their characteristics, what they can do, and what their relationships are with respect to each other. So the behavior of one object changes the contents of another object, or makes an object do, make some other object do something else, and which in turn might trigger more changes and so on. So that is how the whole thing is set up. It is somewhat like an electronic circuit where you have a number of chips and each chip has some influence on some other chips and so on and so forth. So it is kind of it's kind of like that with all these objects looking like chips, and they are getting wired by their relationships. We could think of it like that. And every object has two parts: data. For example, a student object could have the name of the student, the ID of the student, the courses the student has taken, the GPA, etc. as data, and it would have behavior. Behavior would mean things like registering for a class, getting a grade for a class, or the ability to change the name of the student or retrieve the ID of the student, etc. So there are a number of key terms that we will be using repeatedly many times this semester. Object, which you have seen in ICS 141 and 240, and which we just looked at in a few minutes ago. And class is another term that you should all be familiar with. So many objects are similar. For example, all the student objects in a university are similar in certain respect. So we capture that similarity into a software entity called a class. So a class is like a blueprint for an object or a bunch of objects. Interface is like a class without any implementation. It is an abstract specification of functionality. UML is a language for describing a system. Then what we find in an object-oriented system is that there are, or across systems, I should say, are that there are problems that are repeating. When you have a repeated problem, the solution can also be repeated. So if you know of one problem that you have solved before, you can pretty much employ the solution that you had before for solving this problem as well. So those solutions are called the design patterns. So there are standard solutions to standard problems. Then we know about inheritance and composition. Although not all of you might be very comfortable with composition, we will look at this in some detail, but you have to review the material from 240 or 141 and also from the textbook. We'll be using the term conceptual classes when we deal with analysis. When you look at the requirements for a system, you start seeing that there are conceptually some classes involved. For example, when you read about a university, you start thinking that there could be a class called student or a class called faculty. Or when you are dealing with an airline, you might think of a class called flight or a class called employee and so on. So that is just a brief introduction to the nature of object-oriented systems, the kinds of terms that we use in an object-oriented system. So a very rough overview. We'll be seeing the details of all these things in the next 15 weeks. So I'm going to stop this video here, and we'll be talking about the measures of a good software in the next one.